Hello everyone, this is Vishal. I am here to discuss about predictive data analysis solutions. I have around 2 decades of experience in IT. I'm working with Optum, basically in healthcare domain. So in my career, mainly I focused on leveraging technology to improve operational efficiency and data-driven decision making in the healthcare organization. I am expert in designing and implementing, then optimizing data warehouse tailored for healthcare, and have extensive experience with ETL process, data modeling, and regulatory compliances that enabling healthcare provider to unlock actionable insight from complex data sets. My deep domain knowledge combined with a strong technical expertise in data architecture, ETL, and reporting enable me to bridge the gap between the business needs and technology solution effectively, where it is enhancing solutions, enabling predictive analysis, or supporting population health management. I am passionate about transforming raw data into strategic asset that drive better outcomes. So today we are going to discuss about the building a scalable, resilient, predictive analytics data warehouse in healthcare. So this is how basically to improve the care quality while optimizing resource utilization. So when we talk about this topic, let's first discuss that what exactly it is important and how this is going to work in this scenario when we talk about data analysis. This article is basically explore the design and implementation of predictive analytics in data warehouse and modern hospital management system. This also examines the transformation of healthcare operations through sophisticated data management architecture, focusing on the integration of real-time analytics, machine learning, and advanced storage solutions. It also addresses the critical challenges in managing the structured and unstructured medical data, implementing security framework, and ensuring scalability while maintaining performance standard for the critical healthcare operations. In today's world, when we are rapidly evolving healthcare landscape, hospitals are experiencing an digital transformation driven by the imperative to optimize operations, enhance patient care quality, and control escalating cost. If you talk about recent studies, as you saw that here we are showing that 30% of global data, the whole healthcare will represent 30% of all global data by 2025. And that in efficiency gain 37.4%, and the care quality is 42.8% enhancement in patient outcomes using analyticals platform. So the recent studies indicate the healthcare organization implementing data-driven decision-making framework have witnessed a significant 37% improvement in operational efficiency. The integration of big data analytics and artificial intelligence in this healthcare delivery model, with organizations reporting an average reduction of around in administration overhead and a 28.6% increase in resource utilization efficiency when implementing a comprehensive data warehouse solutions. This whole healthcare sector, the digital transformation has catalyzed a fundamental shift in how medical institutions approach data management and analysis. Research indicate that our healthcare organization, leveraging advanced analytics, have achieved a remarkable around 45.3% improvement in predictive accuracy for patient admission pattern and around 33% of enhancement in basically resource allocation efficiency. The implementation of predictive analysis in healthcare is basically demonstrate substantial impact on patient care outcomes and operational efficiency. According to the recent clinical studies, hospitals are utilizing advanced analytical platform. They have reported a 41.6% reduction in preventable readmissions and around 38% improvement in early intervention success rate. The evaluation of healthcare data warehousing has been marked by significant technological advancement and methodological innovations. So when we talk about that when the healthcare institution implementing modern data warehouse system that experience around 47% improvement data processing and 44% enhancement in real-time analytics. The business impact, we can see the cost reductions, resource utilization, infrastructure saving, and decision-making reduction. They all are effectively impact the whole system of the healthcare industry. If we just implement a better and modern way of data warehousing system. The evolution of the healthcare data warehousing is basically marked when we realize that in the healthcare institution implementing the modern data warehouse architecture, they can basically experience around 47% improvement in data processing efficiency and 44% enhancement in real-time analytics capability. As I told you, by 2025, we were around 30% of the global data is all about healthcare. The adoption of cloud-based solutions has further accelerated this transformation, and that enable around 35% reduction in infrastructure cost and 40% improvement in system scalability. These advancements have been particularly impactful in large hospital network, where integrated data platform have facilitated around 40% improvement in cross-facility coordination and around 38% enhancement in resource sharing efficiency. So, implementing a predictive analysis in healthcare will demonstrate an impact on patient care outcomes and also the operational efficiency. This is also shown by all the other studies. When we talk about the architecture analysis, there are multi-layer architecture, visualization layer, analytics layer, processing layer, and data storage layer. So when we talk about this analysis, the foundation of effective healthcare data warehouse architecture is evolved dramatically within the exponential growth in healthcare data complexity and volume. In the recent studies indicate that healthcare organizations are experiencing an unprecedented surge in data generation, with estimates suggesting that the healthcare generates approximately 30% of the world data volume, as I discussed, projected to reach around 2,000 or more than that exabytes by 2025. The emergence of multi-layer architectural approach has revolutionized healthcare data management capability. The research demonstrates that healthcare institutions implementing modern data warehouse architecture have achieved significant improvement in data processing efficiency, with organizations reporting around 67% reduction in data retrieval latency and around 80% improvement in data integration accuracy. The data ingestion layer represents a critical component in modern healthcare data architecture, processing an increasing complex array of data types and sources. When we talk about unstructured data volume are expanding is even more rapid rates. You can see the data is coming in different formats. Unstructured data, more than rapid rates, you can say 60 to 65% per year. This layer must accommodate both real-time streaming data and patient monitoring system and batch processing of administration record, with leading healthcare institutions reporting daily injection volumes exceeding 10 terabytes. Hospitals information system, you can say HIS, have evolved to become increasingly sophisticated, with modern platform managing an average of 8,000 distinct data points per patient encounter. The research shows that integrated HIS platform in healthcare setting process across, you can say, 1.2 million operational transaction daily basis, with peak load during admission and discharge period reaching out up to 3,000 transactions per minute. If we talk about the more how the healthcare data growth and processing metrics, right? So annual metadata growth rate is around 54%. We have to talk about the real-time processing because we are talking patient monitoring, resource allocations, emergency responses, and operational dashboard. As I said, there are 44.3% improvement in real-time analytics capabilities by just implementing a proper and enhanced version of healthcare systems. So when we talk about these systems, we can see that our storage layer architecture. Modern healthcare data warehouse storage architecture have evolved significantly to address the exponential growth in medical data complexity. The structured data storage component leverages dimensional modeling, optimized specifically for the healthcare analytics work. And you can say we are implementing star schema normally in healthcare facilities at implementing a structured data that more than 180,000 daily patient transaction while maintaining sub-second queries response for 88% of analytical queries. Performance analysis from leading healthcare institutions shows that properly implemented dimension models can maintain consistent query performance even when processing a magnitude data spanning 3 to 5 years. Organizations utilizing modern storage optimization techniques have reported compressions ratio average of 6.1 for clinical data, resulting in substantial storage efficiency improvement while maintaining critical performance record. The unstructured data management capabilities have become increasingly sophisticated as healthcare organizations deal with growing volumes of clinical content. Current implementation shows that unstructured data account for approximately 67% of the total healthcare data volume with a typical hospitals, you can say. Modern document stores have around demonstrate significant improvement in test processing capabilities and achieve the success rate. Healthcare organizations utilizing flexible schema design using JSON format have reported a 39% improvement because data is coming in unstructured format a lot. And it will basically reduce the time of data processing and manage around 75 to 100 million documents, while daily injection rate of around 15,000 new documents in a medium to large healthcare facility, you can say. The integration between the structured and unstructured data component through reference pointers has emerged as a crucial architecture feature. In our analytics layer architecture, this analytics layer architecture, if you talk about our analytics layer, if you talk about this layer, where the machine learning models and predictive algorithms come into the picture. In this model, the modern healthcare warehouse has undergone significant evolution to meet the demanding requirements of healthcare operation. The studies demonstrate that healthcare organization implementing a hybrid analytics architecture that achieves a huge improvement in support efficiency and reduction in diagnostic latencies. Stream processing capabilities have evolved to address the complexity of continuous patient monitoring system. With current implementation processing around, you can say, 18,000 events per second from connected medical devices and clinical systems. Our study shows that healthcare organizations utilizing advanced stream processing framework that can identify the critical clinical event around 90% of accuracy within 250 milliseconds. This use. The implementation of real-time operational dashboards has reorganized the healthcare decision-making process. Healthcare facilities report a 40% improvement in resource allocation efficiently and a 38% reduction in response time. The batch processing infrastructure that handles the complex analytics workload that's crucial for the healthcare quality. The ETL workflow in the current healthcare system manages an average of 65 million records daily, with peak processing volume reaching around 120 million records during high demand periods. The organization, we are implementing an optimized ETL pipelines that achieve transformation rates of approximate 1.8 million records per minute. Machine learning models that train the pipelines have demonstrated significant advancement in healthcare analytics. The machine learning pipeline processes an average of 8 terabytes of historical patient data daily. The capabilities for historical trend analysis with modern system efficiently processing 3 to 5 years of historical data, comprising approximately 750 million patient encounters. When we talk about the performance optimization and BI integration strategy, healthcare data warehouse requires is sophisticated optimization strategy to maintain performance at scale. The query performance improve and the cloud storage cost will definitely improve, but it helps to process the record faster. Modern healthcare facilities typically manage between 3 to 5 petabytes of archive active data, with daily query volume reaching around 350,000 analytical requests distributed across various clinical and administrative departments. We are implementing the partitioning strategies that evolve significantly with the introduction of machine learning-driven partition scheme selection. Partitioning framework can reduce query execution time by 60% for time series analysis queries, which represent approximately 58% of analytical workload in healthcare. Healthcare organization implementing smart partitioning typically between 12 to 50 active partition per table. But by using the machine learning integration, the diagnostic support, treatment planning, and readmission prevention, we can see is more than 40% improvement in diagnostic accuracy through the machine learning models. Treatment planning is also improved around 36.7% reduction in treatment planning time. Machine learning help us to improve the whole time. How can we make our time and utilize the time more efficiently? The response time under 150 milliseconds for 88% of frequently executed queries. When you're using columnar storage optimization, that benefited from advanced comparison algorithm and integrated data layout strategy. Integration with BI tool has evolved through the adoption of intelligent query routing and caching mechanism. The data storage optimization, we go with 3 different formats: hot data tier, warm data tier, and the cold data tier. Hot data means what? Basically the high performance in-memory processing for mission critical patient information requiring instant access. For example, real-time monitoring system, active treatment protocol, or fast retrieval of emergency clinical decisions. Warm data, basically the balanced performance cost, SSD storage, high-speed SSD array, comprehensive 30 to 90 days clinical histories, and upcoming appointment scheduling and follow-up. You can say it's called as a warm data, which frequently accessed. Cold data is basically cloud-based archival solution. Secure cloud archiving with compliance certified encryptions. We can regularity compliance records with tamper-proof audit trails. Data will be saved successfully and it will be archived. We are using partitioning approach, machine learning approach for that. Data access layer performance optimization has been revolutionized by predictive query optimization and intelligence caching strategy. Healthcare organization report that machine learning enhanced view modelizations strategy reduced an average report generation time by 58% while supporting an average of 2,800 concurrent query sessions continuously. Modern healthcare data warehouse must address complex scalability challenge while ensuring consistent performance and data accessibility. Our studies indicate that healthcare organization implementing cloud-based scalability and framework achieve around 134% higher data processing throughput and 71% improved query performance during high demand period. In the healthcare domain, where everything is data, and we have to access the data, so query optimization must be improved. We are implementing the query optimization, indexing strategies, data partitioning, and compression techniques. Indexing strategy, that custom healthcare specific indexing patterns, like by which pattern the data will be searched a lot. We can use that pattern to implement indexes to make query performance faster. Load balancing mechanism have evolved to become increasingly sophisticated in healthcare environment. The development methodology significantly influence implementation outcomes in healthcare settings. Organizations start adopting agile implementation strategy, and they can report around 65% of higher project success rate by time to time. The implementation of capacity planning process have become increasingly critical in healthcare environment because data will be stored and need to access from their partitions. Performance optimization process is evolved a lot to incorporate healthcare specific requirements. Organizations report that it will reduce their average execution time and improve the resource utilization and improve the performance. When you make it, there are many challenges because data is coming from the structured data, unstructured data, use volume of the data, a lot of data. So how to integrate with the EHR system, with the legacy system, with the security compliances, unstructured data. This all will be taken care if we balance our system, right, and create our system in such a way so that everything will be managed and enhanced to the query performance. We have to implement our roadmap, assessment and planning, architecture design, pilot implementation, and we have to full development and training. We have to understand how exactly the architecture matters. because a multi-layer design delivered around 48%, you can say, improvement in processing efficiency. You have to focus on the primary goal. Performance would be faster. Patient outcome as a primary goal. Stakeholder involvement is very necessary. Build compliances into a foundation, not as per afterthought. So just one thing here I want to say in the last, that the implementation of predictive analysis data warehouse has fundamentally transformed modern hospital management by enabling data-driven decision making across all operational aspects. Healthcare organizations adopting these sophisticated architecture frameworks have demonstrated significant improvement in patient care quality, operational efficiency, and resource utilization. The success of these implementation relies on carefully balanced architecture decisions that address the unique challenges of healthcare data management, including the integration of diverse data sources, real-time processing requirement, and significant security standard. And the evolution of machine learning enhanced optimization strategy, coupled with advanced storage solution and analytics capabilities, has created a robust platform capable of supporting both current operational needs and future scalable requirements. As healthcare continues to generate increasingly complex and a lot of volume of data, the importance of well-designed predictive analysis data warehouse becomes even more critical for maintaining high-performance healthcare delivery system while ensuring patient data security and regulatory compliances. So it is very required how to make our system in a much better way. Thank you so much for joining this session. Thank you.